Software development methodologies. A method is an action, a way of doing something. Methodology is a structured set of methods, practices, processes and procedures used to achieve a particular goal. Software development methodologies are the methods by which software is produced. Common software development methodologies are: build and fix, waterfall method, incremental method, spiral method, clean room, joint application development, rapid application development and agile. Build and fix model: software developer creates the first version of the program, build, and based on the needs of the customer, software is repeatedly modified, fix, until it satisfies the customer. Waterfall method is a sequential design process in which progress is downwards like a waterfall through the phases of requirements, design, implementation, testing, deployment, and maintenance. Incremental model is a method of software development where the product is designed, implemented, and tested incrementally, added each time until the product is finished. Spiral method is a model of progressive software development that repeatedly passes through phases of planning, risk analysis, engineering, and evaluation. The clean room model is based on producing software with a certifiable level of reliability by avoiding software defects. Joint application development, JAD, is a methodology that involves the client or end user in the design and development of an application. Prototype methodology is defined as a software development model in which a prototype is built, tested, and then reworked when needed until an acceptable prototype is achieved. Rapid application development is a software development methodology that uses minimal planning in favor of rapid prototyping. Agile methodology is a practice that promotes continuous iteration of development and testing throughout the software development lifecycle of the project. Agile methodology practices are: Dynamic Systems Development Method, DSDM, Scrum, Extreme Programming, XP, Test-Driven Development, TDD, Lean Software Development and Minimum Viable Product, MVP. Dynamic Systems Development Method, DSDM, is a framework that is made up of 8 principles, a life cycle, and products, roles and responsibilities, and several best practice techniques. Scrum is a framework within which people can address complex adaptive problems, while productively and creatively delivering products of the highest possible value. Extreme Programming, XP, is an agile software development framework that aims to produce higher quality software and higher quality of life for the development team. Test-Driven Development, TDD, is a software development process where code-level testing guides software design and implementation. It is based on the repetition of an extremely short development cycle: write a test, run tests, write code, run tests until it passes, refactor, then repeat. Lean Software Development, LSD, is an agile framework based on optimizing development time and resources, eliminating waste, and ultimately delivering only what the product needs. Minimum Viable Product, MVP, is a product and development style that produces just enough features to satisfy early customers and enough to provide feedback for directing future product development. Maturity models. Maturity model is a tool for process improvement. Maturity model shows how capable an organization or system is of achieving continuous improvement. Maturity model provide framework for envisioning the future, the desired state, and the development of improvement plans. Maturity model provide benchmarks for the organization to compare its processes internally or externally. Maturity model provide mechanism to provide insight into the improvement path from an immature to a mature process. Maturity model provide disciplined method that is easy for management to understand and implement. Capability Maturity Model Integration, CMMI, is a process-level improvement program created to integrate an assessment and process improvement guidelines for separate organizational functions. CMMI for Development, CMMI Dev, describes best practices for the development and maintenance of products and services across their life cycle. CMMI for Services, CMMI SVC, is a comprehensive set of guidelines to help organizations establish and improve processes for delivering services. CMMI for Acquisition, CMMI ACQ, describes best practices for the successful acquisition of products and services. People Capability Maturity Model, PCMM, has key capabilities and best practices to improve people management. Capability Maturity Model Integration, CMMI, maturity levels are initial, managed, defined, qualitatively managed, and optimizing. Initial, also known as Maturity Level 1, describes an organization whose processes are ad hoc or chaotic. Managed, or Maturity Level 2, indicates that processes at this level are planned and executed according to organizational policy, and the management has visibility on work products at defined points. Defined, or Maturity Level 3, relates to processes that are described in standards, procedures, and methods. Qualitatively managed, or Maturity Level 4, is when an organization uses quantitative objectives for quality and process performance as project management criteria. Optimizing, or Maturity Level 5 emphasizes continuous improvements through quantitative and statistical methods as well as by responding to changing business needs and technology. Building Security in Maturity Model, BSIMM, is a descriptive, software security-focused maturity model based on actual software security initiatives. Software Assurance Maturity Model, SAMM, is a framework to help organizations formulate and implement a security software strategy that is tailored to the specific risks facing the organization. Software Development Life Cycle, SDLC, Operation and Maintenance. The operations and maintenance phase in software development life cycle, SDLC, is the end of the beginning. Operational problems require operational solutions. Operational solutions focus on controlling access, inputs, and variability. Visibility of the software and its environment is a significant component of control. Logging and monitoring are essential for operational information. Maintenance functions are a natural part of operations. Maintenance activities are bug fixing, upgrade and enhancement. Bug fixing. Bugs are reported because of some scenarios which are not tested at all. Upgrade. Upgrading the application to the newer versions of the software. Enhancement. Adding some new features into the existing software. Change management. Change is the addition, modification, or removal of anything that could have a direct or indirect effect on services. Change management is the formal business process that ensures all change must be controlled. Identify and characterize the need for the change. Make a formal request for change by submitting a ticket for the change request. Assess the change request. Approve the changes and associated development activities. Implement the change request in a repeated routine of code changes and testing until the change requirements are sufficiently completed. QA tests and verifies that the change is sufficient. Promote the code to the next deployment stage, which could be production. Report changes to management for their review. The person or group who authorizes a change is known as a change authority. 3 types change are standard, normal and emergency. Standard changes are pre-authorized and implement without additional authorization. For example, OS upgrade, deploying patch, setting up an user account. Normal changes are authorization-based and low risk. Emergency changes are changes that must be implemented as soon as possible, for example, to resolve an incident or implement a security patch. Integrated Product Team. Integrated Product Team, IPT, is a multi-talented group of people from different disciplines responsible for delivering a product. Integrated Product Team ensure that all of the required roles, skills, knowledge, and personnel resources available to make product development, or software development, more efficient and effective. Integrated Product Team consists of software developers, quality assurance staff, product management, project management, and designers. Each specialty brings a unique focus, input, and decision-making to the software development process. Integrated Product Team comes from Integrated Product and Process Development. Integrated Product and Process Development, IPPD, is a management technique that came out of industry to improve competitiveness and customer satisfaction. Integrated Product and Process Development, IPPD, is driven by the customer's needs. Integrated Product and Process Development, IPPD, integrates software development activities, from requirements gathering and analysis to support, to optimize the overall software development process. Integrated Product and Process Development, IPPD, provide insight into its purpose and practice. Customer focus. Concurrent development of products and processes. Early and continuous life cycle planning. Maximize flexibility for optimization and use of contractor-unique approaches. Encourage robust design and improved process capability. Event-driven scheduling. Multidisciplinary teamwork. Empowerment. Seamless management tools. Proactive identification and management of risk. An agile team is a form of integrated product team. Clear and effective communication is the cornerstone of agile methodology, and development concepts, techniques, and ideas are integrated within the team's dynamic. The agile team management and communication patterns connect them with other teams, expertise, and entities in an organization for necessary information flow and access to these resources as needed. Agility, automation, rapid development, and frequent delivery of working software, new working styles emerged. This integration of disciplines and technology has come to be known as DevOps. DevOps breaks down the wall between developers and operations. DevOps enables continuous integration and continuous deployment. DevOps accelerates software delivery and increases software quality and security. DevSecOps is the merging of security with DevOps. DevSecOps takes the DevOps role, automation infrastructure, and workflows and builds in security techniques and continuous attention to security. DevSecOps provides a set of values that include an excellent summary understanding of what drives DevSecOps. DevSecOps values are: leaning in, data and security science, open contribution and collaboration, consumable security services with APIs, business-driven security scores, red and blue team exploit testing. 24/7 proactive security monitoring, shared threat intelligence and compliance operations, programming languages security. Language has been our primary mean of communication and human interaction for thousands of years. Programming language is a computer language programmers use to develop software programs, scripts, or other sets of instructions for computers to execute. C and C++ are critical low-level programming languages. C and C++ access to low-level IT infrastructure such as RAM and system processes, which if not well protected, hackers can easily exploit. C programming language is the backbone of most operating systems. C programming language is a lean, flexible, and efficient language that can be used to complete a wide range of tasks such as cryptography, image processing, and socket networking. C++ is regarded as C's big brother. C++ is a fantastic language that is largely based on C's source code. There are several cybersecurity programs created using C++. For example, Nmap, the network mapper tool, is created using C++. Personal Homepage, PHP, language is designed as a scripting language specifically for rapid development of database-driven web pages with quick and convenient database access. PHP is written in C, so it can inherit the security vulnerabilities from an insecure implementation of its parent language. Ada language designed for military, avionics, and real-time systems, was designed with an emphasis on safety and security. Safety and security required by the types of software programs set high standards for the Ada language. Java is another language that is designed with security built in. Security aspects of a programming language are safe typing, safe pointers, safe architecture, safe paradigm implementation, safe object construction, memory management, garbage collection, invalid access protections, safe and managed error and exception handling, safe startup, safe communication, safe concurrency, deadlock detection and resolution, security patterns and frameworks, secure execution environment, developers' security expertise.
Open source software. Open source refers to something people can modify and share because its design is publicly accessible. Source code is the part of software that most computer users don't ever see. It's the code computer programmers can manipulate to change how a piece of software, a program or application works. Open source software is computer software whose source code has been made publicly available. LibreOffice and the GNU image manipulation program are examples of open source software. Open source software benefits are flexibility, community, variety, licensing options, low cost, and security. A developer can modify open source software to meet their specific functional needs. Open the source, change the code, assure that it works and is safe and secure, and then use it. It is easy to recognize the knowledge, sharing, and passion of the community of people involved in open source software projects. Open source contributors code for free. There are many open source projects that meet a wide variety of software needs. Open source licenses affect the way people can use, study, modify, and distribute software. Not all open source licenses allow for the code they cover to be freely used within other software. Open source software cost is, mostly, free. The source code is free. Well-documented and comprehensive security policy is needed to realize benefits of the use of open source software. All open source software should be thoroughly evaluated before its use by an organization. Do not allow administrators or users to download or install any unsanctioned open source software to critical environments. All open source software to be installed and used in an enterprise environment should be sanctioned by the organization. Download open source software only from trusted sites. Prefer open source software source code to binaries wherever possible. Conduct vulnerability scans on the open source software. Disable unwanted services from open source software. Follow a defense in-depth strategy to ensure the secure use of open source software. Open source software maintenance and operations must be audited periodically. Training and documentation are important for open source software security management. Consider open source software in disaster recovery and business continuity plans. Database Management System, DBMS. Data is a collection of facts, such as numbers, words, measurements, observations, or just descriptions of things. A database is a structured collection of data. For example, structured SQL database. A database management system, DBMS, is a software application that manages databases. A database management system, DBMS, allows for the definition, creation, querying, update, and administration of databases. Standards such as SQL provide some degree of interoperability between database management system, DBMS. Protocols such as Open Database Connectivity, ODBC, or Java Database Connectivity, JDBC, allow applications to use Database Management System, DBMS, functionality. Database Management System, DBMS, functionality falls into four main classifications: data definition, update, retrieval, and administration. Data definition allows for the creation, modification, and removal of database definitions. Update facilitates the insertion, modification, and deletion of the actual data. Retrieval provides information in a form that is usable to the calling environment. Administration facilitates registering and monitoring users, enforces data security, monitors performance, maintains data integrity, manages concurrency control, and provides recovery of information in the case of an unexpected system failure. A database management system, DBMS, provides a data definition language, DDL, a data manipulation language, DML, and a data dictionary. A data definition language, DDL, is a computer language used to create and modify the structure of database objects in a database. A data manipulation language, DML, is a computer programming language used for adding, inserting, deleting, and modifying, updating, data in a database. A data dictionary contains metadata, data about the database. Deployment environments. A deployment environment is a relatively isolated information systems environment that is dedicated to the requirements and hosting of particular classes of applications and services. Standard deployment environments are known as development, integration, test, staging, and production. Each standard deployment has its level of trust and security. Software changes are made in the development environment. This environment is typically a developer's workstation. The integration environment is where developers' changes are combined and compiled together. The integration environment is used to verify code quality, safety, security, and integration. The test deployment environment is the next stage of quality control where various automated quality measures and tests. The staging environment is used to test all installation, configuration, and migration scripts and procedures before they are applied to the production environment. The production environment is when the software goes live. Configuration management as an aspect of secure coding. Configuration management is a fundamental aspect of secure coding. Configuration management is maintaining a durable configuration history. Configuration management is providing a foundation for a secure coding environment. Configuration management is creating secure baselines. Configuration item is a service asset that needs to be managed in order to deliver an IT service. Configuration management system holds all the information about configuration item within the designated scope. For example, a service configuration item will include the details such as supplier, cost, purchase date and renewal date for licenses and maintenance contracts, related documentation. A baseline is an agreed description of the attributes of a product, at a point in time, which serves as a basis for defining change. A version is a concept that describes the unchangeable state of a configuration item, a set of configuration items, and a baseline. A change set is a group of related changes to configuration items that have been changed, and it is the basis of how changes to the software system are controlled. A branch identifies a set of versioned configuration items that are being developed in parallel to the main configuration. A main branch is the base configuration from which all other branches are derived. Security of code repositories. What is source code? In computing, source code is any collection of code, possibly with comments, written using a human-readable programming language, usually as plain text. The source code of a program is specially designed to facilitate the work of computer programmers, who specify the actions to be performed by a computer mostly by writing source code. The source code is often transformed by an assembler or compiler into binary machine code that can be executed by the computer. The machine code might then be stored for execution at a later time. Alternatively, source code may be interpreted and thus immediately executed. Repository refers to a central place where data is stored and maintained. A source code repository is an archive with the code as well as the hosting facility for these software. Source code repositories, including GitHub, GitLab, Bitbucket, SourceForge, and others, confidentiality, integrity, and availability need to consideration when determining the best method to protect your source code. Security challenges in use of code repositories. Internal threats including disgruntled employees, careless actors, contractors. External threats such as hackers. Ransomware. Denial of service. Disclosure or theft of sensitive data or intellectual property. Destruction of sensitive data or intellectual property. Assess the effectiveness of software security auditing and logging of changes. Logging provides an authoritative record of activities and events in a system. Audits are used to discover information on operational effectiveness as well as to provide evidence related to an organization's compliance. The security capabilities of logging and auditing work together to address specific concerns in the software development environment. Security capabilities of logging and auditing are error and exception management, source code management, operational environment logging, detecting authorized and unauthorized changes, running software security oversight, performance management, configuration changes, cloud environment changes, changes in security posture, security incident response, security control verification, security information and event management, forensics, PCI, HIPAA, MARS, and Omnibus. Error and exception management is the process of handling problem situations in running software. Fatal is when there is a problem with the program or service that require its termination. An error is a problem for an operation but not for the overall program or service. Warn is for events that may cause unusual application behavior. Info is any useful information about the system to be logged. Debug should be reserved for development purposes to improve the code. Trace should be reserved for development purposes where there is a need to trace into a part of a function's execution. Source code management is a business and technical process that controls the record, management, sharing, and versioning of source code. Source code management core features are source code accountability, source code integrity, and verification. Source code accountability traces all changes made back to the original developers who committed the changes so that when problematic code or configurations are identified. Source code integrity reveal program modifications that either converge or diverge from requirements. Verification is the process of ensuring the completeness and correctness of the code. Logging captures events that occur in the operational environment. Detecting authorized and unauthorized changes is one of the most effective ways to support security. Software running in a production environment is the front line of cybersecurity. Logging events that have a security impact supports security oversight of running software. An example of an event with a security impact is multiple login attempts, which may indicate unauthorized access attempts. Performance in the operational environment should be maintained at a service level that satisfies customers. All configuration changes should be traced to an approved requirement for the change. All changes to the cloud environment should be logged according to organization's security requirements. An organization's security posture is based on its security policies, standards, guidelines, and procedures. Security-related event logs can be sent to Security Information and Event Management SIEM System. Security Information and Event Management SIEM System analyzes and correlates security events to discover and respond to security situations. Security Control Verification confirms that a security control is performing as expected. Security Information and Event Management SIEM provides real-time information on security events. Forensics is the scientific process of collecting, analyzing, and presenting evidence. The Payment Card Industry Data Security Standard, PCI DSS, is maintained by the Payment Card Industry Security Standards Council. The Payment Card Industry Data Security Standard, PCI DSS, was created in 2004 by MasterCard, Visa, Discover, JCB, and American Express to establish a universal platform to prevent fraud when credit card information is being transmitted. HIPAA is U.S. legislation that provides data privacy and security provisions for safeguarding medical information. MARS-E version 2.0 provides security guidance that supports the mandates of the Patient Protection and Affordable Care Act of 2010 and the Department of Health and Human Services, HHS. The HIPAA Omnibus Final Rule, put into effect in 2013 by the U.S. Department of Health and Human Services, was instituted to modify the HIPAA to provide patients with more flexibility and control over their personal health information and strengthen the existing HIPAA privacy and security protections of health information. Risk analysis and mitigation. A threat is newly discovered incident that has the potential to harm a system. Worms and viruses are categorized as threats because they could cause exposure to an automated attack. A vulnerability is weakness of an asset that can be exploited by attackers. A weakness in a firewall that lets hackers get into a computer network. Risk is defined as the potential for loss or damage when a threat exploits a vulnerability. Examples of risk include financial losses, loss of privacy, reputational damage, legal implications, and even loss of life. Risk equal threat multi-B vulnerability. Risk analysis is an effort to identify vulnerabilities and their related threats, assess the potential cost of exploitation, and determine appropriate and cost-effective security controls. The following are 4 goals of risk analysis: Identify the assets to protect. Identify the assets' vulnerabilities and related threats. Provide realistic information on the probability and impact to an organization of a risk's occurrence. Determine the best way to handle the risk based on a cost-benefit analysis of different ways to manage the risk. Risk analysis methodologies are CISSP 800-30, Risk Management Guide for Information Technology Systems Octave Allegro ISO IEC 27005 Failure Modes and Effect Analysis, FMEA, Fault Tree Analysis, NIST SB 800-30, Risk Management Guide for Information Technology Systems Focus is on information technology threats and their relationship with information security risks. The NIST SB 800-30 risk assessment activities are as follows: System characterization, threat identification, vulnerability identification, control analysis, likelihood determination, impact analysis, risk determination, control recommendations, results documentation. Octave stands for Operationally Critical Threat, Asset, and Vulnerability Evaluation. Octave is a framework for identifying and managing information security risks created by the Carnegie Mellon University's Software Engineering Institute, SEI. Octave phases are: Phase 1, Build enterprise-wide security requirements. Phase 2, Identify infrastructure vulnerabilities. Phase 3, Determine security risk management strategy. Octave Allegro is designed for an organization to assess information security risks but within time, staff, and resource constraints. Octave Allegro methodology consists of the following steps: 1. Establish risk measurement criteria. 2. Develop an information asset profile. 3. Identify information asset containers. 4. Identify areas of concern. 5. Identify threat scenarios. 6. Identify risks. 7. Analyze risks. 8. Select a mitigation approach. ISO IEC 27005-2008, Information Technology, Security Techniques, Information Security Risk Management, is an international standard for risk management practices within the context of an information security management system, ISMS. Failure Modes and Effect Analysis, FMEA, is a structured and systematic process to determine failures and the effects of those failures. Fault Tree Analysis is a top-down failure analysis approach that deductively analyzes failure events in a system. Risk analysis are two approaches: quantitative risk analysis and qualitative risk analysis. Quantitative risk analysis examines risk that can be measured numerically or monetarily. Quantitative risk analysis core concepts are: asset value, AV, exposure factor, F, single loss expectancy, SLE, annualized rate of occurrence, ARO, annual loss expectancy, ALE. Asset value, AV, is the value of an asset to an organization. Exposure factor, F, is the potential percentage of asset loss caused by an identified threat. Single loss expectancy, SLE, is the percentage loss of value to an asset expected from the realization of a risk. Annualized rate of occurrence, ARO, is the annualized rate of occurrence is the probability that a risk will occur within a year. Annual loss expectancy, ALE, is the percentage loss of value to an asset expected from the realization of risk over a year. Annualized rate of occurrence, ARO, is the estimate of how often a given threat might occur annually. L is the expected risk factor of an annual threat event. The risk that remains after the implementation of countermeasures is known as the residual risk. Total risk equals threats times vulnerability times asset value, AV. Residual risk equals total risk minus security controls, also known as countermeasures. Qualitative risk analysis considers risks based on their likelihood, impact, and severity. There are 4 different ways an organization can treat risks: reduction, transfer, avoidance, or acceptance. Risk reduction is the process of reducing the risk to the point where it is acceptable to the organization. Risk transfer is when risk is legally assigned to a third party. Risk avoidance is when an organization chooses to deflect or terminate situations that cause a risk. Risk acceptance is the assumption of risk. Assess security impact of acquired software. An acquisition is a process through which one organization buying another organization. For example, Bharti Airtel acquired Zine Africa, February 2010. When an organization acquires software, it also acquires the risks related to that software. Commercial off-the-shelf, COTS, software is software that are ready-made and available for sale to the general public. For example, Microsoft Office is a COTS product that is a packaged software solution for businesses. Software development outsourcing describes a situation in which an organization chooses to hire a third-party programmer to offer services related to software development. Open source software is computer software whose source code has been made publicly available. The process to acquire software has the following 4 phases: planning, contracting, monitoring, and accepting follow-up. In planning phase, organization performs a needs assessment, develops the software requirements, creates the acquisition strategy, and develops evaluation criteria and a plan. In contracting phase, organization creates a request for proposal, RFP, or other supplier solicitation forms, evaluates the supplier proposals, and negotiates the final contract with the selected seller. In monitoring and accepting phase, organization establishes the contract work schedule, implements change control procedures, and reviews and accepts the software deliverables. In follow-up phase, organization must sustain the software, including managing risks and changes. The Capability Maturity Model Integration for Acquisition version 1.3, CMMI ACQ v1.3, model provides best practice guidance to an organization for applying CMMI when acquiring products and services. Software assurance is the degree of certainty that software is free from vulnerabilities of all kinds and that its functionality meets all expectations required of it. 7 principles for software assurance are: 1. Risk drives assurance decisions. 2. Risk concerns shall be aligned across all stakeholders and all interconnected technology. 3. Dependencies shall not be trusted until proven trustworthy. 4. Attacks shall be expected. 5. Assurance requires effective communication among technology participants. 6. Assurance shall be well planned and dynamic. 7. A means to measure and audit overall assurance shall be built in. Certification is a technical evaluation of a software system's security compliance with specific standards to which it should conform. Accreditation is that management understands the overall security of the evaluated system and formally accepts the risks, security weaknesses and vulnerabilities at the source code level. A software weakness is a bug, flaw, or error in the software. A weakness can be in the architecture, design, or code of a program. Common examples of software weaknesses are buffer overflow, format strings, authentication errors, insufficient data validation, code injection. The common weakness enumeration, CWE, and the OWASP Top 10 are 2 sources of reference to software weaknesses. The common weakness enumeration, CWE, is a community-developed list of common software and hardware security weaknesses. The OWASP Top 10 Most Critical Web Application Security Risks list is an essential resource for the security practitioner.
OWASP Top 10 Application Security Risks are: injection, broken authentication, sensitive data exposure, XML external entities, XE, broken access control, security misconfiguration, cross-site scripting, using components with known vulnerabilities, insufficient logging and monitoring, cross-site request forgery. Injection vulnerabilities. Injection vulnerabilities are flaws that allow attackers to inject malicious code in another system using an application. When an application accepts user inputs and allows these inputs to enter a database, shell command, or operating system, making application susceptible to an injection flaw. These flaws are result of insufficient input validation. Common types of injection flaws are SQL injection, command injection, LDAP injection, XPath injection, and XML injection. SQL injection, where attackers insert malicious SQL code into a SQL database to provide unauthorized access to private data. Command injection is an attack in which the goal is execution of arbitrary commands on the host operating system via a vulnerable application. LDAP injection is an attack used to exploit web-based applications that construct LDAP statements based on user input. Similar to SQL injection, XPath injection attacks occur when a website uses user-supplied information to construct an XPath query for XML data. XML injection is an attack technique used to manipulate or compromise the logic of an XML application or service. Broken authentication. Broken authentication is the breach in the authentication procedure of a web application. Broken authentication vulnerabilities are plaintext passwords in transit, plaintext passwords at rest, weak passwords, single-factor authentication, password guessing, man-in-the-browser attack, and session hijacking. Plaintext passwords in transit transmits a clear text password via an HTTP connection, then user's password will be communicated in plaintext and at risk from eavesdropping. Plaintext passwords at rest means that anyone who looked through the database would be able to just read the user's passwords. Weak password is a password that is easy to detect both by humans and by computer. Single-factor authentication is a process for securing access to a system, identifies requesting access through only one category of credentials. Password guessing is the process of attempting to gain access to a system through the systematic guessing of passwords. Password guessing can be prevented by using a CAPTCHA. Password guessing can be prevented by delaying subsequent login attempts after each failure. Password guessing can be prevented by locking out the account completely. Man-in-the-browser, MITB, attack utilizes a Trojan horse in a pre-infected device/system to infect the Internet browser, and sniff, capture and modify information as it travels between the user interface of the infected browser and the Internet. Man-in-the-browser attack can be mitigated to do not install browser extensions or add-ons from untrusted sources. Man-in-the-browser attack can be mitigated to keep your operating system and browser up to date. Man-in-the-browser attack can be mitigated to install and update anti-malware. Session hijacking refers to an attacker's ability to take over a portion of a session and act as one of the participants. As users interact with a web application needs to keep track of which requests came from which users. Session tokens are used to connect disparate HTTPS requests to a single user. Session tokens can be compromised by guessing and brute force. Guessing: secure session tokens must be generated by a cryptographically secure pseudo-random number generator. Brute force: secure session tokens must be long enough, at least 128 bits. Session tokens must also be invalidated when the user successfully logs in and logged off. Sensitive data exposure occurs when an application or program does not adequately protect information such as passwords, payment info, or health data. Sensitive data exposure vulnerability. Transmission of sensitive data in the clear. Lack of appropriate HTTP security headers used to mitigate the possibility of man-in-the-middle attacks. Incorrectly configured HTTP headers. Weak ciphers. Storing user passwords in plaintext. Extensible Markup Language, XML, is a standard, platform-independent markup language that defines format rules for encoding data. An attacker could abuse XML features to carry out denial of service attacks, access logical files, generate network connections to other machines, or circumvent firewalls. XML mitigation techniques. Using a less complex file format. Ensuring XML parser library is current. Properly configure XML parser and disable security-sensitive options. Using positive server-side sanitization to validate input and prevent malicious code. Application firewall monitor for XXE attacks. Broken access control occurs when a server does not properly validate every request. Server validates users' access to an admin page, but does not validate the post or get from that page. An attacker with knowledge of the post or get URL bypassing the validation. An attacker who tampers parameters can bypass validation. Always check the identity and authority of user to perform the requested operation on every request. Security misconfiguration can happen at web application, network services, platform, web server, application server, database, frameworks, custom code, pre-installed virtual machines, containers, or storage. Preventing security misconfigurations. Default accounts must be disabled. Unnecessary features and services must be disabled. Error reports must be logged. Security headers must be enabled and properly configured. Cross-site scripting, XSS, is an exploit where the attacker attaches code onto a legitimate website that will execute when the victim loads the website. Cross-site scripting, XSS, attacks can generally be categorized into two categories, stored and reflected. Stored attacks are injected script is permanently stored on the target servers, such as in a database, in a message forum, visitor log, comment field, etc. Reflected attack victim clicking on a carefully crafted link, for example in an email or another website, that sends the attacker's malicious script to the target website. The mitigation is to never trust user input. Using components with known vulnerabilities. Keeping an accurate inventory of all the components of web application is important. Automated vulnerability management tools to scan web application and detected packages against a database of known vulnerabilities. Exploitation of insufficient logging and monitoring is the bedrock of nearly every major incident. Logging must capture all relevant events. Logging must record details. Logging must be centralized. Logging must be immutable. Monitoring should alert when limits are exceeded. Cross-site request forgery, CSRF, is an attack that forces an end user to execute unwanted actions on a web application in which they're currently authenticated. Cross-site request forgery, CSRF, attacks specifically target state-changing requests, like transferring funds, changing their email address, not theft of data. Cross-site request forgery, CSRF, token is a unique random value that is prevent cross-site request forgery attacks.
Security of application programming interfaces. An application programming interface, API, allows an application to communicate with another application, or an operating system, database, network, etc. For example, the Google Maps API allows an application to integrate third-party content, such as locations of places overlaid on a Google map. API security focuses on strategies and solutions to understand and mitigate the unique vulnerabilities and security risks of application programming interfaces, APIs. API Security Top 10 2019. API 1. 2019 Broken Object Level Authorization. API 2. 2019 Broken User Authentication. API 3. 2019 Excessive Data Exposure. API 4. 2019 Lack of Resources and Rate Limiting. API 5. 2019 Broken Function Level Authorization. API 6. 2019 Mass Assignment. API 7. 2019 Security Misconfiguration. API 8. 2019 Injection. API 9. 2019 Improper Assets Management. API 10. 2019 Insufficient Logging. Secure Coding Practices. Carnegie Mellon University's Software Engineering Institute, SCI, produces good coding standards. SAI's top 10 secure coding practices are: validate input, heed compiler warnings, architect and design for security policies, keep it simple, default deny, adhere to the principle of least privilege, sanitize data sent to other systems, practice defense in depth, use effective quality assurance techniques, adopt a secure coding standard, validate input from all untrusted data sources. Compile code using the highest warning level available for your compiler and eliminate warnings by modifying the code. Create a software architecture and design your software to implement and enforce security policies. Keep the design as simple and small as possible. By default, access is denied and the protection scheme identifies conditions under which access is permitted. Every process should execute with the least set of privileges necessary to complete the job. Sanitize all data passed to complex subsystems such as command shells, relational databases, and commercial off-the-shelf (COTS) components. Manage risk with multiple defensive strategies, so that if one layer of defense turns out to be inadequate, another layer of defense can prevent a security flaw. Good quality assurance techniques can be effective in identifying and eliminating vulnerabilities. Develop and/or apply a secure coding standard for your target development language and platform.